Welcome to qnawire.
We're going to have a 65 milliliter sample of 0.3020 molar aqueous solution of benzoic acid. Here you're given the formula, but it is actually just benzoic acid, which is going to have a value of Ka equal to 6.3 times 10 to the minus 5. We are told that this is going to be titrated with 0.1450 molar solution of potassium hydroxide. This is going to be a one-to-one reaction. And essentially what we want to know is, first of all, the initial amount of mole of benzoic acid, which is going to be equal to 65 times 10 to the minus 3 liters, the volume that we're going to get, times the concentration in molarity. So the result over here is going to give us 0.01963 mole of benzoic acid. Now we know that we need to add the same amount of OH minus to reach the equilibrium, to reach the equivalence point. So the volume required of addition at the equivalence point would be equal to the amount of mole, 0.01963 mole, divided by the concentration of the hydroxide, 0.1450 mole per liter, which is going to give us 0.13538 liters that we need to add in order to reach the equivalence point. This means that the total volume at equivalence would be equal to the initial volume plus the volume added, which would result in 0.238 liters of solution. Or you can round it up directly as 0.2 liters. Well, 0.200 liters, which is the same as 200 milliliters. Okay? Regardless, this is going to be our total volume, which we're going to employ to get the concentrations. So now that we know the initial amounts of mole, we know the total volume of solution, what we can do is go ahead and proceed with an ice table. So remember that in our ice table, what is going to occur is that our benzoic acid, I'm going to put BH just to exemplify that this is going to be an acid, plus the OH minus is going to produce the benzoate ion plus water. Over here, we can go ahead with the ice table in terms of amount of mole. We're going to have N0, we're going to add N0 amount. So what is going to happen is that the change would be minus N0, something close to 0, something close to 0, plus N0, and water doesn't matter. So we're going to have essentially N0 amount of B minus. That means that at equivalence point, what we're going to get is that the reaction corresponding to B minus plus water in order to produce OH minus plus HB is going to be the one that is going to dominate our equilibrium. In this case, our ice table is going to be given in terms of molarity, and I'm going to use the value for N0 over the total volume at the equivalence, which is going to be our initial concentration. Okay, we're going to have 0 of everything else. Water doesn't matter because it doesn't enter equilibrium. Over here, we're going to have a change of minus x, plus x, and plus x. So at equilibrium, we would get C0 minus x, and x. This reaction corresponds to the value for Kb, and remember that the product of Ka times Kb needs to be equal to 10 to the minus 14. So Kb would be 10 to the minus 14 divided by the value for Ka, which we said was 6.3 times 10 to the minus 5. Which gives us that Kb is 1.5873 times 10 to the minus 10. So Kb is going to be very, very small. That means that we can employ the small x approximation. This value of Kb would be equal to the concentration of OH minus times the concentration of Hb of the benzoic acid divided by the concentration of the benzoate ion, which would be, replacing the values at equilibrium, equal to x squared divided by C0 minus x. So, in this case, under the small x approximation, C0 minus x is approximately equal to C0. So, Kb would be equal to x squared over C0. So, the value for x would be the square root of Kb times my initial concentration, which is the value that we just calculated, times 10 to the minus 10, times the amount of mole that we're going to have at equilibrium, 0.01963. Yes, 0.01963. Over my total volume, which said was equal to 0.2 liters. So the value would be equal to 3.95 times 10 to the minus 6. Times 10 to the minus 6. This is the value of x that we just calculated. And what is x? Well, x is equal to the concentration of OH minus that we're going to have at equilibrium. So we can calculate the POH, which is minus the logarithm of this concentration, which is going to give us a POH equal to 5.4. And since pH is equal to 14 minus POH, we're going to get a pH equal to 8.6. And this would be our pH at equilibrium. And with that, it would be all. Thank you very much and have a good one.